The last and most advanced option to create your instrument is to use a real programming language to write your own programs controlling your instrument. So as an example, I have created a small curve tracer which uses my power supply together with the DMM shield and the bench multimeter to drive or to place some voltage across an LED and to read the current through the LED as well as the voltage over the LED to get the voltage versus current curve for the device under test. LED is just a simple example, but you can use this for basically any device that you want to use, and you are also not limited to just controlling these three instruments. You can control as many as you want to come up with any solution for your automation tasks that you want to do. So I created a small Python class for each of the instruments here. They are right now very hard-coded. They know on which port my instrument is connected. They have some prepare function which is currently very specific for my test. So for example, the multimeter gets switched to DC voltage with a range of 6 volt with fast measurement. The DMM shield gets switched to DC mode with a range of 50 milliamps, and the power supply needs a bit more setup because it needs to switch on the current, the correct channel in the with the correct settings. And then I'm using my main class to create an TK user interface and then drive the instrument. So the user interface is rather simple. It creates a canvas with a reasonable size, creates a button to connect to the interfaces, a measurement button, has two text fields to output the current measurement values that I have, has some input fields. One is for the start voltage, so where should the curve start with driving the device under test. Then one for the maximum voltage, so even though the logic will limit the current through the diode, there should be some maximum voltage that you want to apply. You have a step voltage, meaning how many measurements you will take, and you have a cutoff current, which defines what's the maximum value that you actually want to drive through the LED. So for example, if we have a low power LED, it's probably several milliamps. For a normal one, they can easily drive 25 milliamps or so. Then you have some functions that you connect to the buttons. So when you press the connect button, you actually connect to your instruments, check whether this works, and if it does, you can activate the measurement button, and if you press the button again, it will disconnect the instruments so you can start again. The measurement function will read all of the values from the input fields and then really start the measurement. While the measurement is running, the measurement button gets disabled and it gets enabled afterwards. For the measurement itself, first the power supply gets turned on. The current limit is set to twice the cutoff current. So the power supply itself should limit any current. So even when you set the start voltage too high, you should not destroy your device under test as soon as your current is reasonable. Then you turn the power supply on, wait a little bit for the voltage to settle, and then you start your measurement loop where you change the voltage in your defined steps and measure all of the values. Afterwards, you turn the power supply off, and then you use the values, voltage and current that we created, and create a nice plot with from these values. That's one of the reasons I chose Python for the sample program. One is it has a nice library for actually driving such instruments, and the other one is it really comes with a lot of libraries, for example doing measurement, mathematical analysis, or also creating figures with, in this case, just 7 lines of code. The actual measurement loop is rather simple. We run through our voltage range, execute one single measurement, which means setting the voltage on the power supply, again waiting a bit, measuring current and voltage, and then we take these measurements here, store them to our internal list of values, and as in the last step we just check whether the currently measured current is larger than the cutoff current, and if it is, we stop the measurement regardless of whether we actually reached the the final voltage or not. And then again we go back to our measurement function here and would create the final curve. So let's have a look at how this actually looks like.